Hi everyone, welcome back to the Sun Devil Learning Lab. My name is Miss Alford.
And I'm Mrs. Hilton, and today we're going to be talking about how to use the Pythagorean Theorem to measure distance on a coordinate plane. You're going to need a piece of paper, something to write with, and possibly a calculator. Let's go ahead and get started.
So just like Mrs. Hilton just said, we are going to be using the Pythagorean Theorem to find distance. Our objective for today is I can determine the distance between 2 points on a coordinate plane using the Pythagorean Theorem. So maybe you're asking, well, what is the Pythagorean Theorem? Or maybe you've heard of it before, or maybe you watched the videos that we made this week, so you know exactly what it is we're talking about. Well, we're just going to do a little bit of a recap. So the Pythagorean Theorem states if the lengths of the legs of a right triangle are A and B, and the length of the hypotenuse is C, then A squared plus B squared equals C squared. So we know that we have two legs, A and B. It's a right triangle, and then the hypotenuse is C. So we can also say with the Pythagorean theorem that given a right triangle, A, B, and C, with C, this angle being the vertex of the right angle, we have our right angle. We know this is a 90-degree angle right here for this. Then the sides A and C and B and C are called the legs of this right triangle ABC. And then A and B is called the hypotenuse. So with the theorem that we just read off in the first bullet, we know that the lengths of the legs of the right triangle, so we have A and B, these are our legs, and then our C, which is the hypotenuse. And these sides, A and C, B and C, like I said, are the legs. And then we also have our 90-degree angle, our right triangle. So we have the same triangle here that we just looked at, A, B, and C. And we know that this C is the hypotenuse. Well, we also know that the C, this hypotenuse, is always going to be diagonal from the right angle. So we have our C right here, we have our 90-degree angle, and wherever the hypotenuse, whatever direction the right triangle is facing, whether it's flip-flop, whether it's upside down, or just looks different than this, the hypotenuse is always going to be diagonal from the 90-degree angle. So that's an important note to take when maybe trying to determine which side is the hypotenuse. And with that, it does not matter which leg is A or B, because as long as the numbers are only used once in the equation, you are fine. It can go A squared plus B squared. Maybe this side is 3 and this side is 5, so 3 squared plus 5 squared equals C squared. Or it can go the other way, 5 squared plus 3 squared equals C squared. So you can flip-flop them. They can go in whatever order you feel, but they can only be used once, and that's important. But as far as the hypotenuse goes, you always need to know that it's diagonal from the right angle, because that number is going to be different than the legs. Okay.
In today's lesson, we will be using the Pythagorean Theorem to help solve for missing values for lines on the coordinate plane. Let's look at an example of what this might look like. On this graph, we see 3 lines that form a triangle. Line AB is in red, line BC is in blue, and line AC is written as a dashed diagonal line. Using this graph, we see that line AB equals 3 and line BC equals 4. Can we use the Pythagorean theorem to figure out what line AC equals? What do you think? Remembering that A squared plus B squared equals C squared, we can substitute the length of the two legs in our equation. So we can use the length of AB, which is 3, for our A value, And we can use the length of BC, which is 4, for our B value. And then we'll solve for C, which will be our hypotenuse. So 3 squared plus 4 squared equals C squared gives us 9 plus 16 equals C squared. Then we can add 9 and 16 together, which gives us 25. So C is going to be equal to the square root of 25. The square root of 25 is 5. And if C equals 5, we can say that line AC also equals 5. So our hypotenuse is equivalent to 5 units. Any set of 3 positive whole numbers that satisfies the Pythagorean theorem is called a Pythagorean triple. Other examples of Pythagorean triples are these. They can be in proportions other than the set of 3, 4, 5. Take a minute to look over these different multiples and note any observations that you can make about them. One important thing to note about Pythagorean triples is that they are a set of numbers that work perfectly in the Pythagorean theorem. Their proportions remain constant as the triangle sides get larger.
Okay, so now let's take a look at 2 points on this coordinate plane. We have point A and we have point B. What is the distance between these 2 points? So when you look at these 2 points, right off the bat, what is the distance? Maybe you take a second to count, but we're gonna count together. 1, 2, 3, 4, 5, 6. So the distance between point A and point B is 6 units. Okay, so we have our 2 points, A and B, and the distance between the two of them is 6 units. Well, now let's take a look at another coordinate plane and let's find the distance between point A and B. So up here we have point B and over here we have point A. So pause the video and take some time to think about how you might find the distance between these 2 points. So what's different between these 2 points we are seeing right now on this coordinate plane and the ones we just looked at? Well, the line connecting point A and B is not vertical or horizontal. It's not a straight line. It's not going vertically or horizontally. It is a straight line, but it is going diagonally. Therefore, we cannot count the units like we did. We can't go 1, 2, 3, 4, or we can't go 1, 2, 3, 4, 5, 6. That just doesn't make sense because it's not exact. We don't know. So what do we do? That's the big question. What do we do if we have 2 points that don't connect on a vertical or horizontal line? Well, we just learned about the Pythagorean theorem, and that allows us to determine the length of an unknown side of a right triangle. Okay, but this isn't a right triangle, so what are you thinking? What thoughts come to mind? How can we make this a right triangle? So, like I said, how do we use the Pythagorean theorem to connect points A and B and to find the distance between those two? Well, we know that the Pythagorean theorem can only help us determine the side of a right triangle. So that means we need to draw a right triangle so that the hypotenuse, so that that diagonal line we just saw is the hypotenuse. Okay, and we can do that by drawing a vertical line through point B. So right here we see these red lines. This one, a vertical line through point B, and then drawing a horizontal line through point A, all the way through, horizontal and a vertical. But we still have our diagonal line right here. Or if you do it the other way around, which is perfectly okay, you can go vertical angle through A and then a horizontal line through B. And that would just like flip-flop the right flip-flop the triangle, but either way is perfectly fine, as long as they meet up at some point. So next we want to mark the intersection of the horizontal vertical lines as point C. So like I said, they met at a certain point. Our horizontal and our vertical lines met right here at point C. And this made a right angle. Therefore, we now have a right triangle. And we know that we use the Pythagorean theorem when we have a right triangle, and this looks like something we can use the theorem for. So first, let's find what is the length of A to C. What is the length of this segment right here? Well, let's count. 1, 2, 3, 4, 5, and 6. Okay. And then what is the length of B to C, this side? 1, 2. So our side AC is 6 units and our side BC is 2 units. Now that we have our legs, which are going to be the smaller sides of the triangle, we can find the hypotenuse by using the theorem, the Pythagorean theorem. A squared plus B squared gives us C squared, our hypotenuse, which is always diagonal of the right angle. So let's do it. So we know that our A to C is 6 units, and then our BC is 2 units. So we're going to apply this equation. A squared plus B squared equals C squared. Well, we can keep them either as AC equals 6 units or BC, but we also know that these sides, we just call them A or we call them B. And you can do, like we said, when it comes to the legs, you can do them whichever way as long as they're only used once. So I decided to do this side is A and that side is B. So 6 squared plus 2 squared equals C squared, which is 6 squared is 36 plus 4, 36, and then, 2 squared is 4, which gives us our C squared, and we still don't know that. But 36 plus 4 is 40, and the way we get rid of a square is by finding the square root, and when we find the square root of 40, it gives us an answer of 6.3, which is, it's not an exact answer, so that's why we use this estimate. So C equals 6.3, because that is the square root of 40. It's not an even square. It's not like taking 25 and finding the square root. So and gives us a whole number of 5. But our hypotenuse here, C, is 6.3, and it is still bigger than this side AC, and the hypotenuse is always going to be the longer side. So now let us do an example, and I'm going to ask you to pause at certain points or reflect or think, or maybe just kind of figure out on your own, or maybe you just keep watching the video and if you're not understanding too well, and we can do it together. But first, we're going to find the distance between the points A and B on this coordinate plane. So we have a bigger segment this time. So A to B. Since the horizontal and vertical lines are already drawn for you here, find the distance between AC and BC. Use those distances to find the distance of the hypotenuse C. So once we find these, we can then plug them into our equation, A squared plus B squared, and we can get C squared. So like I said, pause the video, you have the graph, or you have the coordinate plane, and you have the lines. If you want to do this on your own, feel free to do that. Maybe write it down, draw it down, whatever you need to. Grab a calculator. But let's go. So the distance of AC is 5 units. 1, 2, 3, 4, and 5. And the distance between BC is 6 units. 1, 2, 3, 4, 5, and 6. So our BC plus AC is going to give us our AB. This should say BC squared. Remember, for the Pythagorean theorem, it's always A squared plus B squared. So that is my apology there. So A squared plus B squared equals C squared. So we have side A, side B, and side C. So I chose to make this side A and this side B. So 6 squared plus 5 squared equals our C squared, our hypotenuse. That is 36 plus 25, and that equals our C squared. Well, 36 plus 25 is 61. So how do we get rid of a square? We find the square root of the number. So the square root of 61 is 7.8. Like I said, this is not a whole number. This is, so it's like the closest thing we can get to the right number. So it's going to be 7.8 because 61 does not have a perfect square. So C, our hypotenuse, is going to be 7.8, which, like I said, 5, 6, 7.8 is still bigger.
In this next slide, we will use the Pythagorean theorem to determine if a triangle is a right triangle. Looking at these points, is the triangle formed by the points A, B, and C a right triangle? How can we verify if a triangle is a right triangle? What do you think? Pause the video to think of what might work. We can use the converse of the Pythagorean theorem. To do this, we need to know if the lengths of all three sides. Then we can check to see if the side lengths satisfy the Pythagorean theorem. Looking at this triangle, we can see that line AB runs along the x-axis, and clearly we can count from point A to point B is 10 units. How can we determine the length of line AC? It's marked here in orange. When we apply the Pythagorean theorem, we need to remember to look for other triangles that can help you to solve for missing values. To find line AC, the length of line AC, we can draw a horizontal and vertical line to form a right triangle and use the Pythagorean theorem to determine the length. If we're going to have C in our equation represent line AC, we know that line AD and line DC will be our A and B values in our equation. So we can write for AD, our line measures 1 unit, so we'll have 1 squared as our first value there. Then our second leg of our triangle is DC, and it measures 3 units, so we write that as 3 squared. And then C is going to represent our unknown value for line AC, and that's going to be C squared. Then we can see that we have 1 plus 9 equals C squared after we factored the exponents. We add those together and we end up with 10 equals C squared. And then we're going to stop right here by saying that C equals the square root of 10. We want to remember to leave our answer in square root form unless it makes a perfect square. Now try to determine, see how you think you could determine the length of line BC, which is here marked here in orange. You can pause the video to try and solve this. To find the length of line BC, we can draw a horizontal and vertical line to form a right triangle and use the Pythagorean theorem to determine the length. The legs of our triangle will be line CE and line EB. So we can see that line CE is 9 units long if we count that out, and line EB is 3 units. So we'll use those as the legs of our triangle, which means C in our equation will represent line BC, which will be our unknown value. So we substitute into our equation a squared plus b squared equals c squared. We're going to use 9 squared plus 3 squared equals our unknown value c squared. 81 plus 9 equals c squared. 81 plus 9 equals 90, so we have 90 equals c squared. And then again, we're going to leave this equation solved at c equals the square root of 90 so that we can, since that's not a perfect square. Now that we know the length of each side, we can determine if this is a right triangle or not. So let's look at these values. The lengths of the 3 sides of the triangle are 10 units, square root of 10 units, and square root of 90 units. Which number here represents the hypotenuse of the triangle? The side AB must be the hypotenuse because it is the longest side. We know that from our rules that follow the Pythagorean theorem. When estimating the lengths of the other 2 sides, I know that the square root of 10 is between 3 and 4, and the square root of 90 is between 9 and 10. Therefore, the side that is 10 units in length must be the hypotenuse because it is the longest. So we can see those values filled in here where they would belong on our triangle. And now we can use the Pythagorean theorem to determine if this is a right angle triangle. We know that if it is, these values will add up to be equal on both sides of our equation. So using these lengths, 10, the square root of 10, and the square root of 90 to determine if the triangle is a right angle, pause the video and write what you think the equation would look like. We're going to begin by filling in our data for a squared plus b squared equals c squared. We'll start here with the square root of 10 with an exponent of 2. Then we're going to have the square root of 90 squared, and then we have equals 10 squared. Simplifying this, we can see that the square root of 10 squared is going to give us 10. The square root of 90 squared is going to give us 90. And then we're on the other side of our equal sign, 10 squared equals 100. Adding these 2 numbers together, we can see that we get 100 equals 100. So both sides of our equation balance, which can tell us that, yes, this triangle is a right angle triangle. This proves that the points A, B, and C form a right triangle. In today's lesson, we've learned the following things in relation to the Pythagorean theorem and how we can use it with a coordinate plane. To determine the distance between 2 points on a coordinate plane, we have to do these 3 steps. First, we connect the 2 points on the coordinate plane. Then we draw a vertical line through one of the points and a horizontal line through the other point. The intersection of the vertical and horizontal lines forms a right triangle, to which the Pythagorean theorem can be applied. Second, we learned that we can verify if a triangle is a right triangle by using the converse of the Pythagorean theorem, where we figure out the values and then see if they are equal. Thanks for sticking with us through the lesson and doing all the different examples. If you need to do more practice, you can always check the learning guide for videos and more activities. Thank you.
Thank you. Bye, guys.